We're going to continue our study on radicals by talking about how to multiply radical expressions. Now, when we multiply radical expressions, this is going to be different from when we add and subtract radical expressions. So if you remember, when we add and subtract radical expressions, we had to have the same thing under the square root in order to combine them. That's not the case when you're trying to multiply radical expressions. If you have the square root of a times the square root of b, you're going to multiply what's under the square root together. So it becomes the square root of a times b. All right, let's take a look at our first example. Multiply the following expressions. Be sure to write your answer in simplest form. All right, so anything that's outside of the square root will get multiplied to each other, and anything inside the square root will be multiplied to each other. So in this first one, 7 root 6 times 9 square root of 18. I can multiply the 7 and the 9, and that's 63. That goes outside of the square root. And then the 6 times 18, that's equal to 108, and that goes under the square root. So we have 63 square root of 108. Now, with the 108, we want to see, even though we've multiplied it correctly, it did say to write your answer in simplest form. So we want to check to see whether or not square root of 108 is in simplest form. So we're checking to see, are there any factors of 108 that are perfect squares? Well, it looks like 36 is a perfect square. That's also a factor of 108. So I can rewrite the square root of 108 as the square root of 36 and the square root of 3. Now I can simplify the square root of 36, and that becomes 6. So we have 63 times 6 times root 3. And then I'll go ahead and multiply 63 and 6, and that gives me 378. So my answer for this problem in simplest form is 378 root 3. All right, let's do an example where we have variables. So we have the square root of 8x cubed y squared times the square root of 10xy cubed. All right, so everything's under the square root, so we can multiply all of this and it will all go under a square root. So that would be the square root of 80, x to the fourth, y to the fifth. Now we need to see if this is in simplest form. So check to see, are there any perfect squares that are factors of 80? Yes, 16 is a perfect square that is a factor of 80. X to the fourth itself is a perfect square. And then we can take out a y to the fourth from the y to the fifth and write that under the first square root as well. So I'm going to have 16x to the fourth, y to the fourth, and that leaves me with 5y under the second radical. Now I can simplify that first radical. The square root of 16 is equal to 4. Square root of x to the fourth is x squared, and the square root of y to the fourth is y squared. So we're left with 4x squared y squared times the square root of 5y. And that's my answer. All right, let's take a look at example 2. Now in these examples, we have the square root of 3, or some square root, and then in parentheses, we have 2 terms. So we're going to have to distribute what's outside of the parentheses to what's inside the parentheses. So we are multiplying because distributing is a form of multiplication. We just have to make sure we multiply both of the terms, or if there are more than 2 terms, all of the terms inside the parentheses. So in this first one, we'll do root 3 times 2. That's equal to 2 root 3. And then root 3 times negative 5 root 2, that's going to be minus 5 root 6. Double check to see whether or not there's anything we can simplify. So the square root of 3, that's as simplified as it can be. And the square root of 6, that's as simplified as that can be. So that's our answer, 2 root 3 minus 5 root 6. Remember that we can't subtract those radical expressions because what's under the square root is not exactly the same. So we won't be able to combine 2 root 3 and minus 5 root 6 any further. All right, for the second example here, we have 2x times the square root of 5y, and then all of that times the square root of xy minus 3 times the square root of 5x. All right, we'll take it one at a time. Remember that when you're multiplying, anything that's under the square root gets multiplied with anything under the square root. Anything outside of the square root gets multiplied with anything outside of the square root. So we have 2x times the square root of 5y times the square root of xy. So that's going to be 2x times the square root of 5xy squared. And we'll do the same thing with our next term. So now I'm going to multiply the 2x and the negative 3 and the 5y and the 5x. So that's going to give me minus 6x times the square root of 25xy. All right, now again, at this point, we want to see, is there any way for us to simplify what's under the radicals right now? So the square root of 5xy squared, do we have any perfect squares? Yeah, that y squared is a perfect square that can come out. So the square root of y squared is equal to y. So we'll end up with 2xy times the square root of 5x. And in the second one, 25 is a perfect square. Square root of 25 is equal to 5. So we'll end up with minus 6x times 5, and then the square root of xy. All right, we can write that 6x times 5 as 30x. And now, comparing what's under the radical, under one radical we have 5x, under the other radical we have xy. So we won't be able to combine these any further because between these two terms it's subtraction, and we can't add or subtract radicals unless what's under the radical is the same. So that's as far as we can go with that. All right, taking a look at example 3. Here we have some binomial expressions multiplied by other binomial expressions. So here we just have to make sure that we're keeping track of everything we're multiplying. So for this first one, we're going to multiply 4 times 5, and then 4 times 4 root 2, and then 2 root 2 times 5, and then 2 root 2 times 4 root 2. All right, let's start with 4 times 5, so that's 20. Then 4 times 4 root 2 is 16 root 2. 2 root 2 times 5 is 10 root 2. And then 2 root 2 times 4 root 2 is 8 root 4. Now we want to see if there's anything we can simplify here. Now definitely the square root of 4 at the end, that's a perfect square. So that's the same as 8 times 2, which is equal to 16. And then lastly, we can combine anything that has the same radical. In this case, the 16 root 2 and the 10 root 2 can be combined. And then the 20 and the 16 can be combined. So we have 36 plus 26 root 2. All right, let's look at the next one. We have 4 minus root 3 times 2 minus root 3. So we'll do 4 times 2, which is 8. Then 4 times negative root 3, so minus 4 root 3. Negative root 3 times 2, so that's minus 2 root 3. And then negative root 3 times negative root 3, and that's equal to positive square root of 9. All right, the square root of 9 is equal to 3, so we can replace that there. And then we have negative 4 root 3 and negative 2 root 3, which can be combined to be negative 6 root 3. And then the 8 and the 3 can be added together to be 11. So this is going to be 11 minus 6 root 3. All right, let's look at the next one. We have 3 minus root 7 times 5 plus root 7. So let's do 3 times 5, that's 15. 3 times root 7, that's 3 root 7. Negative root 7 times 5, so minus 5 root 7. And then negative root 7 times positive root 7, so that's negative square root of 49. All right, the square root of 49 can be simplified to 7. And now we can combine the 15 and the minus 7 to be 8, and the 3 root 7 and the minus 5 root 7 to be negative 2 root 7. So we're left with 8 minus 2 root 7. All right, our last example, we have 6 minus root 5 times 4 plus root 5. All right, again, let's just make sure we multiply everything out. So 6 times 4, that's 24. 6 times root 5 is 6 root 5. Negative root 5 times 4 is minus 4 root 5. And negative root 5 times root 5 is negative square root of 25. All right, square root of 25 at the end there can be simplified down to 5. And then now we can add 24 and the negative 5, and that gives us 19. And then the 6 root 5 minus 4 root 5 is equal to 2 root 5. So we have 19 plus 2 root 5. And that's our answer.